In this video, we're going to go through the basic types of chemical reactions. But before we get started, there's a couple of things I want to review. In this unit, we're going to be writing a lot of chemical reactions, so I want to review some rules for that. When we write our chemical reactions, we need to indicate the states. So we know solid, liquid, and gas. A solid is indicated with a little s after the element or compound, liquid with a tiny l, gas with a little g, and aqueous with AQ means dissolved in solution. So if something like sodium chloride is indicated as aqueous, we know that that means the ions are separate and in solution. So when you're writing equations, you have to indicate what state each piece of the equation is in. The next thing we need to review is balancing reactions. Now you're going to get a lot of practice with this, but just to review, balancing reactions has to do with the conservation of mass. Your reactants, or what you start with, must be equal with your products or what you end with. Atoms don't just disappear, so we have to have the same atoms in the reactant side as we do in the product side. Let's look at an example. Let's say we have ethanol reacting with oxygen to make carbon dioxide and water. On the reactant side of the equation, on the reactant side of the reaction, we have 2 carbons, 6 hydrogens, and 3 oxygens. Now on the product side, we have 1 carbon, 2 hydrogens, and 3 oxygen. For this to be a balanced reaction, we need to have the same number of each type of atom on each side of the arrow. Now it takes a lot of practice to know where to start, but I know if this element is by itself, oxygen, I'm going to adjust this last. Now I see that we need 3 times as much hydrogen on this side, so I'm going to go ahead and make this hydrogen 6 by multiplying this whole thing by 3. That changes this from 2 hydrogens to 6. It also changes the oxygen, so I added some oxygen here, so now I have 3, 4, 5 oxygen, and I did not change my number of carbons. But if I do change my carbons, I would need to put a 2 here to make it 2 carbon. And now my carbons match, my hydrogens match, my oxygens don't match. But I have changed this from 2 oxygens to 4 oxygens, so now I have 4, 5, 6, 7 oxygens. So how do I get 7 oxygen on this side? Well, I already have 1, so this will have to be 6, which is easy. I just multiply 2 by 3, and now I have 7 oxygens. 6, 7. And now this equation is balanced. So you're going to get a lot of practice with this, but just know that a proper equation is well balanced, and it has the states indicated in brackets for each of the elements or compounds. And now we're ready to talk about types of chemical reactions. There are 5 main types of reactions we're going to talk about in this video. We're going to talk about synthesis, decomposition, single displacement, double displacement, and combustion. First, we're going to talk about synthesis reactions. The word synthesis essentially means putting things together. So in a synthesis reaction, a compound is made from combining simpler materials. For example, solid magnesium can combine with chlorine gas to make magnesium chloride. Now it's important to remember that each of these substances is completely unique. Magnesium is completely different than chlorine gas, which is also completely different than magnesium chloride. It's not like this is half of magnesium and half of chloride and behaves half and half. It behaves completely differently than either of these two things. Each of these substances is a unique substance with unique properties. So combining things doesn't make a hybrid substance. These things are all different. In this video, aluminum is combining with mercury to make something called an amalgam of aluminum mercury. So the aluminum and the mercury are combining to make something completely different than either one of those substances. So when we're talking about synthesis reactions, we're taking one substance, combining it with another substance to make something completely new. The second type of reaction we're going to talk about is called a decomposition reaction. The word decomposition has the word decompose in it, so you're decomposing something or breaking it down. A decomposition reaction is when a compound is broken down into simpler compounds or even into its elements. For example, the decomposition of water breaks water down into oxygen gas and hydrogen gas. Now to balance this, I need to double the oxygens in water. That also caused me to double the hydrogens, so now it's balanced. So water breaks down into hydrogen gas and oxygen gas in a decomposition reaction.
So, we have this material here called copper carbonate. We're going to add some heat, and we're going to break it down into some parts. What do you think it's going to break down into, guys? You can't break it down into itself. What is it going to break down into? Carbon dioxide, volcanoes. All right, we've got a variety of answers. Let's see what they have. Now, some people said carbon dioxide, and I think that maybe they're right. How can we tell if we're creating carbon dioxide? It's colorless. All right, that's difficult to tell. We can see bubbles, maybe. So here, we've got in a sealed container. So, glass tube, there's a rubber bung, a tube, and that goes into some water here. So I can see if there's bubbles being produced, and that might tell me it might be carbon dioxide. But that could be any gas. I could get oxygen gas, I could get carbon dioxide gas. We don't know which one it is. So, to help tell the difference, I filled this one here not with water, but with quicklime. Or lime water, whatever. Lime water reacts with carbon dioxide and it makes it precipitate. So if we see this change into a cloudy color, we know it must be carbon dioxide. If not, it might just be the oxygen or something like that. So, let's put it down here in the triangle and see what happens. Heating the copper carbonate. Now, why is that? Has this done anything? Can you see anything changes? No, I think what's happening is that maybe just the air inside is also expanding, so it's pushing out. So when it starts reacting, you'll know. Look at that! Look at that! Now look at the other tube. So what does the test tell us? What's it made out of?
Carbon dioxide.
Alright, so they're creating carbon dioxide gas. Yeah, before everything goes wrong, I have to unplug it.
So in that video, we had copper carbonate decomposing into carbon dioxide and solid copper. For a decomposition reaction, it's the opposite of synthesis, taking something complicated and breaking it into simpler compounds. Next is the single displacement reaction. We've actually done these reactions in the lab before. A single displacement reaction is when one element that starts out by itself replaces another element in a compound. This was like when we had solid magnesium and copper chloride solution, and the magnesium switched places with the copper to create a magnesium chloride solution. This is because magnesium is more reactive than copper, so it kicks it off and replaces it.
But anyways, that's my 1.6 grams of silver nitrate, and now we're going to dissolve that in about 25 milliliters of water. Silver nitrate is very soluble, so this should dissolve in no time at all. Okay, I've got my solution made, and now I'm just going to toss the little coil of copper wire into it. See, almost immediately, we get a change to start happening. So the copper wire has started to tarnish, maybe. Now it's only been a few minutes, so we can see there's a really clear change has happened. So we started out with a clear solution, which we put a reddish metal into. And now what we're ending up with is what looks like a white or silvery colored metal, and the solution started to turn blue.
So this is our clear solution with our solid copper. And we ended up with solid silver and a blue copper chloride solution. So we end up getting the other element by itself. Next type is a double displacement reaction. This is where the positive and negative ions in two compounds switch places. Let's look at this example. You can see in the reactants that barium is with chloride and sodium is with sulfate, but in the products it switches. Barium is with sulfate and sodium is with chloride. That's a double displacement reaction. In this next example, you're going to see lead nitrate mixing with potassium iodide.
Pour these together and take two aqueous solutions and see if a precipitate results. Now, precipitate is when a solid comes out of the solution, because we're going to do a double replacement, or something called a metathesis reaction. Lead plus 2 from this beaker is going to attract and hook up with the iodine ion to make PbI2, or lead-2 iodide. And that is going to create a precipitate, because the lead iodine prefers itself more, or attracts itself more, than water. So let's do that. Here we go. Very brilliant reaction. You see that's pretty, very pretty yellow precipitates.
So for the products, we get solid lead iodide, that is yellow, and potassium nitrate. In a double displacement reaction, the positive and negative ions switch. So now A is with B and C is with B. The last type we're going to talk about is combustion. And this is where a compound containing carbon and hydrogen, and sometimes oxygen, combines with oxygen to make carbon dioxide and water. There are a few different types of combustion reactions that we're going to talk about later, but this is the basic one we're going to talk about today. This is where something flammable, like this methane gas, combines with oxygen gas to create water and carbon dioxide.
We'll demonstrate for you a combustion reaction. So here we go. So what I'm doing now is this. I am putting in some methane into some soapy water. And what that does is that then creates some methane bubbles. It's basically just a lot of methane that's just trapped into bubbles. Please do not take a sample. Even if you have access to that. Okay? So here we go. Very sweet. One more time. So that is our combustion reaction.
So with a combustion reaction, you're starting with a hydrocarbon, you're combining it with oxygen, and you're looking for these two products, water and carbon dioxide.